This presentation is brought to you by the SDG Decision Education Center.
I'd now like to introduce today's moderator, Dr. Bruce Judd. Bruce has 40 years of experience in training executive teams in aspects of decision quality. He is the founder and leader of the Decision Education Center at Strategic Decisions Group. Bruce, you have the floor.
Thank you, Kat. And let me extend my welcome to everyone who has joined us today on the topic of the value of information. Today's webinar is one of a series that draws on SDG's many years of supporting clients with complex decisions and with corporate strategy. SDG was founded in 1981, and this year the firm celebrates its 40th anniversary. We're pleased to have with us today is Dr. Eric Bickel of the University of Texas at Austin. At UT, Eric teaches courses and leads research in decision analysis and its application to business and public policy. He's the academic director of the Strategic Decision and Risk Management Certificate Program, which is a collaboration of SDG and UT's McCombs School of Business. He is also a partner and a member of the board of directors of SDG. Eric, welcome to today's webinar.
Thank you, Bruce. Pleasure to be here.
Also with us today is Troy Helm, who will be answering your questions as they come into the program. So, Eric, before we get started on today's topic, we have a poll for our participants. The question we'd like you to answer is gathering more information, for example, more data, before making a decision always a good idea? And as you can see on the screen, the choices are yes, more information is always better, no, and maybe.
Yeah, I see the results coming in here. Quite interesting. So make one of the three choices. Looks like the results are stabilizing, Bruce.
Yeah, so let's just give a couple more moments and then we'll close the poll. Yeah, it looks like it has stabilized, so let's close the poll. Aha, strong preference there for maybe. Several people say no, gathering more information, more data before making a decision is not always a good idea. And we have a few who say yes, more information is always better.
Yeah, maybe we shouldn't have given people the easy way out with the maybe.
It force people to choose. Okay.
Okay, Bruce. Well, thank you. Thank you for that, and thank you for everybody for completing the poll. And we had, I think, about 10% of the people said that it always makes sense to gather more information. So that will be interesting, and we're going to keep you in suspense regarding the correct answer to that question. So just in terms of the webinar itself, some objectives and what I hope to convey to everybody today. The first, I think, important point is really the ubiquity of this concept of value of information. I think we've all certainly experienced that idea, that concept in our own personal decision making. And also encounter it quite a bit in our professional environment. I'd like to talk about that a little bit. The next would be to define what we mean by the value of information and how would we calculate it. Third point is what has to be true for information to have value. Does information always have value? Could it have no value? Could it have a negative value? I'll demonstrate how to calculate VOI in a simple situation, and I think that'll give you the concept, and of course how to do it in more complicated settings would be something we'd have to go into separately. And then I want to show that we can and we must place a value on information before it's gathered. What we're talking about here is not ex post. We're not saying, well, was it a good idea to get that information after we've seen it? We have to pay for information before we gather it. Therefore, we'd like to have an idea of its value beforehand. And then talk a little bit about how VOI plays an important role in many projects. Okay. So here's just a few examples, and I'm sure you could have many more, and be interested in hearing about some of those. These are, I think, common situations where the value of information plays an important role. The first one here, pharmaceutical company thinking about developing a new vaccine to treat COVID-19. Of course, there's a lot of uncertainty. Is the vaccine going to work? Is it safe? Is it effective? What's the right dose? And they go through clinical trials in order to resolve those questions. And then they make decisions based on that information, like what the dose should be, or should we release the vaccine or not. Something you'll see a little bit later, kind of near and dear to my heart right now, a recent high school graduate, unsure where she wants to attend college, so she arranged a campus visit. Online social media company collects data on its users, and they use this information to decide which advertisements to show and to whom. So there's a company where its entire business model is based on VOI. An investor's uncertain about the price of a stock. Is it going to go up or not? So they decided to purchase an option, which allows them to make that decision at a future date. So there's a future action we're taking that provides additional information. And a couple other examples, oil and gas company deciding whether it should conduct a reservoir simulation to inform the development of an offshore field. The company felt this study wouldn't really change their development plans at all, but a partner insisted on conducting the study because they had some guidelines, investment guidelines, which had a checkbox for conduct a reservoir simulation. And then public policy example, how much we should reduce carbon emissions depends heavily on how sensitive the Earth's climate is to additional concentrations of CO2. And there's a number called the climate sensitivity, which is if CO2 concentrations were doubled, what would the increase in temperature be? And the federal government is funding research to narrow the uncertainty regarding that parameter. Okay, so I think it's an interesting collection of personal decisions, business decisions, making decisions to give us more information in the future, cases where maybe we're just getting information because that's the way we've always done it, or there's a checklist that says we should do it. We need a way to think about all these different examples. Okay, so what we want to do today during the webinar, 3 sections. The first is just a quick review of decision quality and how VOI is related to that. And then want to dig into defining VOI and showing you some examples. And then we'll wrap up. As Bruce mentioned, this is the 40th anniversary of SDG. And of course, SDG invented decision quality and popularized its use. And there are 6 elements. And fundamentally, the issue is how do we define a good decision? And what we've identified are 6 elements that you really need to focus on to make sure that you can make a good decision. And they're shown here in this DQ chain, we call it. And I'll just hit them quickly and then point out the ones that we're really focused on. The first is framing. We need to know what problem we're trying to solve. That's really important when you're thinking about gathering information, because as you'll see, how much information is worth is very context dependent. And if you don't have the right frame, you're not going to place the right value on the information. Alternatives, your decisions know better than your best alternative. Okay? If you have a limited set of alternatives, information is going to be worth less. And if you had only one alternative, there's nothing else you could do, as you'll see, then information wouldn't have any value. The third element is meaningful and reliable information. This is really where we're focused today, is how do we think about putting a value on that? How do we know when we have enough information? Then we have values or objectives. We need to know what we're trying to achieve in order to make a good decision and what trade-offs we're willing to make, and sometimes that's not clear. We've had some other webinars on that topic. And then reasoning, this is the analytics, this is putting all this together. We've assessed these different elements of decision quality, and we've got to make sure we put it all together in the right way and reach the right conclusions. And I think that and information are very much what we're focused on today. The final piece is what we call commitment to action, and we really need to have all the stakeholders are involved and build in commitment and ownership to decisions along the way. And you can read more in the book there, and then of course at University of Texas, we offer courses in decision quality and other topics, and I'll mention that at the end of the webinar. Okay, so let's dig into value of information. Here's a simple example that I alluded to at the start. My daughter's a senior in high school, and she's deciding which college to attend. She was admitted to UT Austin, but she doesn't want to attend UT. Why? Well, because her dad's there and her brother's there, which makes it even worse. And I can't say that I blame her. And so she insists under no circumstances, very categorical, under no circumstances will she attend UT. And so the question would be, well, should we go on a 2-hour campus tour? What's the value of that information? You know, perhaps we have a busy schedule, maybe the weather doesn't look so good. Do we really want to go on this 2-hour campus tour? And the answer to that is the value of that information is 0 if she really is stuck here and under no circumstances will she attend UT, then it's not a good use of our time to go on the campus tour. Now, this is just a simple example. Let me give one more, and then Bruce might have something for me. Let's suppose you've gone on a trip, you've gone to Mexico, or you've gone somewhere else. You come back, you're not feeling so well, and you go to the doctor, and she explains to you she wants to give you a rather unpleasant test. And of course, you're an aficionado of decision making, and you ask, well, what are you going to do with this information? What if it comes back positive, which is of course bad? And she says, well, I'm going to treat you with penicillin. And you say, well, what if the test comes back negative? What will you do then? And she says, well, I'll still treat you with penicillin just to be safe. Okay. So you're thinking to yourself, wow, gosh, why don't we skip the test and let's just go to the penicillin? So she's interested in a diagnosis. You're interested in getting better. Right? You're interested in the decisions that you can make. And in this case, the decisions from your perspective are no different. Let's treat you with penicillin. So this information would not have any value. And I think that's an important distinction that I'll hit on the next slide, decision-making versus diagnosis.
So Eric, as you know, questions come in along the way. Here's one, I'd like your take on this. So how do you think of data versus information versus insight? How do you distinguish those three?
Yeah, that's tough. So to me, data would just be numbers, for example, right? Not organized, not pulled together in some way that means something to me. Once it means something to me, then I would say that's information. And in terms of insight, for me, it's all about decision making. So is that information going to lead me to make any different choice or not?
Good. Okay, thank you. And there's another term that we could have thrown in there, another noun, which is knowledge, right? Data, yeah. Information, knowledge, insight, etc. Okay, it's time for another poll. Suppose you, those of you who are participating today, are facing a big decision and can obtain some information for free. Could that information ever have a negative value? Yes, no, and there's our maybe again. Let's
Yeah, we were too gentle here with the maybes.
give people enough. Well, you'll be happy, I think, when you see these results. But let's hold the poll open for just a few more moments. We may have hammered the maybes too hard, Eric. I don't know. Okay, so it has slowed down. So let's close the poll, remove the suspense. Yeah, we've almost got it completely beaten back. But many people are saying, yes, it can. And of course, the question was, if it's available for free, could it ever have a negative value? It looks to me about 60% saying yes, 26% saying no, and 13% saying maybe. So how do you take that, Eric?
So that's interesting. Let's flag that, and I'm going to present a couple slides which might help provide a little bit of a resolution there. But I flagged that about 2/3 say that information could have a negative value. Okay, so let's, from the previous two slides, one takeaway that I want to drive home is information only has value if it could possibly change a decision you're making. I find this very helpful personally, right, and also professionally, right? And it's quite different than what I learned as an undergraduate in engineering. My caveman logic that I learned was uncertainty bad, data kill uncertainty, therefore data good. Okay, this is what I learned, that more information is always better, right? Because we don't like uncertainty, and it's going to make us less uncertain. But as you can see, that just doesn't make sense. If you're not going to make a decision any differently, then the information doesn't have value. Okay, so data and analytics only have value if they hold the possibility of changing decisions. And I think that's quite interesting. We've been doing some machine learning work and integration of machine learning and decision analysis here at UT. And in machine learning, they tend to be very focused on classification, okay, like diagnosis, putting labels on things, where really the only label we're concerned with is it a good decision or not? Should we, which alternative should we pick? And that is really quite a bit different, as you can see in the doctor example. Okay, so we did that poll, and let me present this slide and see if we can understand those results a bit. Let's suppose you're considering the launch of a new product, and you've conducted several market tests, and then a colleague suggests, well, let's do another test, nearly free test, right? And you think gathering more information could have a negative value. Does that make sense? I think there's a couple interesting points to this. One, if you don't have a decision frame, you just gather data forever, right? There's no stopping rule. The decision brings a nice stopping rule. We're done when we're ready to make a decision. And here I'm thinking, well, the information might have a negative value. And what I would say is information can never make you worse off. You could always choose to ignore it. Now, we're talking about important decision situations. I'm not talking about somebody blurting out who done it while you're watching the murder mystery. Okay, would you pay somebody to not know who done it in the middle of the film? Perhaps you would, but I'm talking about important decisions that we're making, and information can't make you worse off. You could decide to ignore it, for example. Now, if more information is going to delay the project or it's going to cost something, that's a separate issue. I'm talking about free information can't make us worse off, because we could change the decisions that we might make. So second takeaway, information value can't be negative, and more information can't make you worse off, but whether or not you should gather it or not, that's going to be a separate question. What is the value of information? That's really the second question that we'll turn to here. And let's look at an example, and this is one that we use quite a bit in our courses. There's a movie company called Ursa Minor Movies, And they're an interesting studio. They can only produce two kinds of films, blockbusters or disasters. And they're going to realize a profit of $20 million if the film's a blockbuster, and suffer a $5 million loss if it's a disaster. If they don't release the film, they've got a net loss of $1 million. Okay. And their current film, it's an interesting film, The Clairvoyant Goes to College, they think has a 60% chance of being a blockbuster and a 40% chance of being a disaster. Okay, we could represent that with a decision tree. And here I have the decision, do we release or not? And that's signified by the square, release yes or no. And then there's an uncertainty, is it a blockbuster or a disaster? 60% chance blockbuster, 40% disaster. And then the profit of the film here, 20 minus 5 or minus 1. Let's suppose this is relatively small potatoes for Ursa, and so they're comfortable making decisions based on the expected value. So 60% of 20 is 12, and then you got to subtract off 40% of 5, and so we get to 10. They should release the movie with no further information, has a value of 10. Okay. Now let's suppose they could learn the movie's fate before they make the release decision. Somebody could tell them this is going to be a blockbuster or this is going to be a disaster. Well, if they knew it was going to be a blockbuster, they'd release it and they'd make 20 million. And if they knew it was going to be a disaster, they wouldn't release and they'd only lose $1 million instead of losing 5 million. Notice this information holds the potential to change their decision. Their release decision is different depending on how this information plays out, which is different than the medical example that I gave you. Well, you just do the math again, 60% of 20 and 40% of minus 1, add those together and you get 11.6. That's better than what they had previously. It's $1.6 million better than if they couldn't learn this information. So this is the value of perfect information in this case. Being able to act knowing whether the film's a blockbuster or disaster makes Ursa $1.6 million better off. Okay, and so this would get us to our definition. The value of information would be the value with free information minus the value without information, the 11.6 minus 10. Now, this is not true in all cases, and this is a more technical topic that we could take offline, but it's generally true in most practical settings that this would be the equation that you would use.
Okay, Eric, we've got another poll queued up here.
Yeah, just I think, okay, go ahead.
Is that all right? So
yeah, let's do that, and then we'll go back.
Oh, I'm sorry, Eric. So in your company, in your organization, do you compute the value of information before you go out and gather it? Choices, always, usually, sometimes, never, and look, there's no maybe.
Let's see how we do on this one.
People are getting to be pretty good at this. We've gotten some pretty quick responses on this.
Looks like always doesn't get a lot of support. That probably makes some sense here.
It doesn't. Things have stabilized. If you want to weigh in on this, do it right away, because in just a couple of moments we will close the polls. Okay, things are relatively stable. So let's close the poll.
Okay.
Yeah, always got hammered.
So it looks to me like there's a lot of opportunity here. Almost 40% never do this, and then about 50% occasionally. So it looks to me like about 90% have the opportunity to add a lot of value potentially.
Yeah, and Eric, with those nevers there, I wonder if we had a question, a possible answer that says, rarely, but we really don't know how to do that. It's not commonly understood within our organization. Hopefully by the end of this webinar, we might have some better understanding.
Yeah. Okay. Thank you. Thank you, Bruce. So the third important takeaway here is we just calculated the value of perfect information for URSA. That was 1.6 million. That puts an upper limit on how much any information gathering activity is worth to them, right? Suppose somebody comes by and they've got a really good sneak preview service for URSA. It's not worth more than 1.6 million, okay? And the value of information is generally easier to calculate than imperfect information, and therefore you can get an upper limit, which is quite important. In your models, you could, or your decisions, you could calculate this value of imperfect or of perfect information on all the key uncertainties, and it would help guide you where you should spend more time improving your model. And if you think about it, we gather information in lots of ways. We do market tests, we do modeling, we conduct interviews, right? We gather and analyze data. A lot of what we're doing on projects is information gathering, right? Most fundamentally, we want to know, is this a good project or not? And the value of perfect information can help guide your work there. Okay, so we know that there's a big opportunity. About 90% of us aren't valuing information commonly. And the question would become, well, I can't get perfect information usually. What about imperfect information? How might I think about valuing that, and what's the process, and what's it worth relative to perfect information? So let's extend this URSA example a little bit. We've got Randy of Randy's Random Movie Testing Service, and Randy just flips a coin to determine whether or not the movie would be a blockbuster or a disaster. Okay, so if it heads, he says this is going to be a hit, and tails, he says this is going to be a dud. Okay, how much would that be worth? Well, it's got to be worth nothing, right? Because he's just flipping a coin. Well, let's just prove that to ourselves. If we had 50 movies, okay, 30 have been blockbusters, 20 have been disasters, and Randy just flips a coin, well, half the time he would have said hit, and half the time he would have said dud, 15-15 or 10-10. And we can calculate these new probabilities. If we don't consult Randy, the chance we're going to have a blockbuster is 30 out of 50. That's 60%. If we know it's a hit, then it's 15 out of 25. Okay, that's 60%. And if Randy says dud, it's 15 out of 25, 60%. Randy's information doesn't change what we think. I think it's clear. If information doesn't change what you think, then it can't change what you do, and therefore it's not going to be worth anything. So his test is worthless. But thankfully, we'll have another testing service here that's better than Randy's, and you can see the value. Okay, so another takeaway is the information has to tell you something about the uncertainty you care about. Randy's didn't, but the data has to be correlated with what you care about but can't observe. All these problems are really the same. There's something we care about but we can't observe. Do you have COVID? How much oil is in the ground? Will the person click on the ad? Lots of things we care about but can't observe. We gather data, though, that is relevant to those things, somehow correlated with those things, which we can observe. Okay, so here's Bruce. Bruce has a sneak preview service, Bruce's superior sneak preview testing service, and he's a better forecaster than Randy. And this has been Bruce's performance over the last 50 movies. Okay, same data, last 50 movies. And we've still got 30 out of 50 that it's a blockbuster. But when Bruce says hit, 20 out of 25 times, the movie's actually a hit, which is 80%, or actually a blockbuster. When Bruce says dud, then only 10 out of 25 times is the movie a blockbuster, or 40%. Okay, so Bruce's information tells us something. It changes what we think. Since it changes what we think, it might change what we do. Okay, whether that's true or not, we're going to have to see. Okay, and notice here, if we believe this data, half the time Bruce says hit and half the time he says dud, so 50-50. Question is, how much is Bruce's test worth? And sometimes people will argue, well, perfect information was worth a lot. It was worth $1.6 million. Therefore, imperfect information's got to be worth a lot. Okay, and I'm referencing a paper here where we do a survey in the oil and gas literature of VOI publications, and this argument is made in some of those papers. Well, let's take a look again. The tree is just a little bit more complicated. Down here at the bottom, we have the same decision that we had previously. If they don't get information, they should just release the movie. If they do conduct the test, then Bruce is either going to say hit or dud. And half the time he says hit, half the time he says dud. Then URSA decides whether or not to release the movie, yes or no. And then here's that 80%. When Bruce says hit, then we think 80% chance of a blockbuster. When Bruce says dud, we think it's only a 40% chance of a blockbuster. And we just solve this tree like we did previously. At this point, the expected value would be 15. 80% of 20 plus 20% of minus 5 is 15. Therefore, if Bruce says hit, we release the movie. Now we go down here, do the same calculation. Here, it's 5 million. And therefore, if Bruce says dud, we release the movie. Okay, so no matter what Bruce says, we're doing the same thing. Now we just have to do 50% of 15 and 50% of 5. And lo and behold, we get 10, which is the same thing we have if we don't hire Bruce. Okay, now this makes sense because notice we're not changing our decision. How much would you pay for information that doesn't change what you're going to do? Well, you should pay nothing for that. Okay, but I know companies that pay a lot all the time for tests like that. So takeaway here is the value of information is very sensitive to its quality or its reliability. Remember, perfect information was worth 1.6 million. Imperfect is worth nothing in this case. Okay, and I've done some research into this, and this is rough, but a rough rule of thumb is if you can quantify the correlation of your test with what you care about, so the correlation between the data and the uncertainty you're trying to assess, let's call that C. Imperfect information is worth about C squared times perfect information, and correlations between -1 and 1, or let's say between 0 and 1. So this is going to be less than 1. For example, if you had a test that has a correlation of 70%, that's only going to be worth about half, 49%, of the value of perfect information. The value of information drops off very, very quickly as the quality of the test degrades. And here's the example in URSA, the correlations between 0 and 1. Bruce's test was down here at 0.4, okay, better than Randy. Randy was here at 0. But you can see, we'd have to have correlations above 0.8 for this information to be worth anything. And so you can't conclude just because perfect information is worth a lot, imperfect is going to be worth a lot. You can't also say, well, if a test has 70% accuracy, it's going to be worth 70% of perfect information. It's generally going to be worth a lot less than that. Okay, and here's the paper where I present that that rule of thumb. Okay, so summary, and then Bruce, we can see if we have other questions. Let me wrap up these takeaways. First is information only has value if it could change a decision you're making. Can't have a negative value. assuming we could ignore it. Okay. The value of perfect information is going to put an upper limit on information gathering. That can be quite helpful in practice because if your information sources cost more than the value of perfect information, then you're done. For example, the value of perfect information is 0, then imperfect information would be worth 0. Any information we gather, it has to be able to tell us something about the uncertainty we care about. So a medical test has to tell us something about our medical condition. The VOI is very sensitive to its quality or its reliability. Okay, and then I think the last important takeaway that I'll add here is that we can place a value on data or information before we gather it. Okay? Not ex post, we're doing this ex ante beforehand. Okay, so Bruce, why don't I pause there, see what questions you have, and then I have a couple of wrap-up slides. Okay, and
as we look through the list of questions that we're getting, and we're getting a lot of them, and they're good questions. But I see a large number related to the question you asked earlier: can the information ever hurt you? And several people are constructing situations where that might be true. The thing you always have to remember, and there's even some questions about in a competitive situation, competitive bidding situation, for example, could information that one of your competing bidders has change their bid, let's say, and that somehow might affect you? So lots of good questions about that. The one thing I think we ought to point out, Eric, is that you always have to put it into a decision context. Now, I've got another one here that I found pretty interesting. Let's do a simple one first. Is there a checklist or a guide that one can use to ensure that time and resources are not wasted on gathering data that has diminishing value? You've reached the point of diminishing returns. Is there a checklist or guide?
Well, I think of these takeaways as being the guide, right? The first thing would be, what's this information going to tell us? Could it possibly change what we think? If no, then you're done, right? If it could change what you think, then the question is, well, could it change what we do? And if the answer to that is no, then you're done. If it could change what you think and what you can do, then the question is going to be, well, is it worth it? Is it economic to gather or not? And I don't think there's necessarily a shortcut in that case. It's going to be context dependent, and you're going to need to do the analysis.
Okay, thanks. And one more observation about the list of questions. We're also getting questions about bias. I'm not going to go into that right now, other than to say that needs to factor in when you're considering the reliability of the information. If that diagnostic test that Eric mentioned earlier has a somewhat high probability of giving you the wrong answer, that could be due to something biased about the test, or it could be biased in the way it's interpreted, etc. Eric, do I have time for one more or not? You be the judge.
One more, and then I'll wanted to mention a couple things at conclusion.
All right. So the concept of cost can often be related to time. The additional time it takes to get additional information that may or may not be essential or has varying degrees of importance to the objective. In other words, can the time affect your decisions about choosing that to gather that information or not to go after it?
Yeah. So when I say cost, I'm speaking broadly, right? And to be clear, cost could be the direct cost, how much we have to pay to get the data, but it could also be indirect in that delay, for example, would be an indirect cost. If it's going to take 6 months to get the data, and we need to make a decision on this in the next 2 weeks, or else a competitor's going to preempt us, for example, then that's a cost of getting the information, would be the delay, and you would need to factor that in. So I don't mean just direct costs. It would also include the cost of doing the analysis, getting the data, for example, getting seismic data, and then processing that seismic data. That's also part of the cost. Okay, well, thank you, and appreciate everybody's time, and look forward to hearing from people, and seeing you on the next webinar.
Yeah, I look forward to that too. So thank you, Eric.